Hi, welcome back. Today we're talking about building your own factor models, a powerful way to explain and predict dependent variables using factors derived from your data. We'll walk through the entire process using a practical finance and investment application for asset returns as a template, which you can recast and apply to your own domain expertise as a data science problem. Point here is that we're going to do factor models as a do-it-yourself guide so that you can use the tools that we're using here for finance in your own domain expertise. So what is a factor model? For investments, a factor model assumes asset returns can be explained by a few common underlying factors plus some idiosyncratic noise. Think of factors as key drivers that influence many assets simultaneously. The market returns, size effects, value effects, and so on. Instead of dealing with hundreds of stocks or assets individually, you model how factors impact returns, which reduces complexity and helps manage risk better. Examples in finance of factor models are the CAPM model, or the capital asset pricing model, or the arbitrage pricing theory APT factor models. And this is done using regression. So you might ask, all right, regression, how's that different from the usual regressions we do? Well, take a look at this equation over here. First one is your usual regression, where you have all of your variables and then you do the multiple regression, versus you transform the regression by first taking a look at factors. They'll explain the variables that move together so that instead of regressing the original set of variables, you're regressing using a smaller set of independent variables, which are now called the factors. So instead of all these variables x1 to x7, for example, we use factors that group the variables together or proxy for the variables. So this is what it would look like in the previous exercises and videos. We showed how this is done. Kindly review the previous videos on PCA and factor analysis if you're unfamiliar with this discussion. But this is crucial. It's with this one where we reduce the number of variables that are used for the regression and concentrate instead on the factors. So what are the steps? We'll go through 4 steps. The first step is getting your data. So first, gather historical price or return data for your assets, maybe stocks, ETFs, whatever you want to model. You also want to have candidate factors, which can be market and macroeconomic data, or it could be accounting ratios like price to earnings, or simply use statistical methods to extract factors from your returns without any predefined factors. You can figure out what those factors would look like, might be, by analyzing the variables. Now, usually you might want to take a look at daily or monthly returns, maybe better if it's longer, like monthly at least, over several years, and that should work well. So the idea here is just get all of your data and put it into the soup. There's a caveat, of course. With more variables, some of them might show correlations by pure chance. We'll talk about that soon in another video. But for now, let's work with putting all your variables together and putting it inside the soup. And note that for QuantProf though, QuantProf Lite, it can only do 10 variables all at once. So step 2 is you run the PCA and factor analysis to extract the factors. We highly encourage you to take a look at our previous videos to know how to work this. And again, the point here is that it reduces dimensionality. Only a handful of factors can be used to represent most of the variation across many assets. And you can run your PCA easily in Excel using QuantProf add-in for our demo exercises. Or if you're doing this large scale, you can use R or even Python. Step 3. Running regression to find factor sensitivities. Once you have your factors, run your time series regressions of each asset returns on those factors to estimate what's called factor loadings, also called factor sensitivities or just simply beta. Mathematically, this is what it looks like in terms of the equation, where R are your asset returns, and F are your factor returns, and B's are the sensitivities. So, for example, you might have this asset, this portfolio, and you want to regress them across 3 factors. So you might have something like this, and the results of the regression, you're going to have this regression results, and we can put that in equation form. This is what it looks like. The data is available. Just take a look at the video descriptions down below. So step 4, using factor sensitivities for portfolio construction. You can now change the factor sensitivities by making changes to the weights of each of the assets that are going to be used to target factor sensitivities. For example, if you're going to build a portfolio with specific factor exposures, you're going to assign weights to assets so that the portfolio overall factor sensitivity hits your target values. Now, this typically involves solving a constraint optimization problem. However, we haven't discussed optimization per se just yet. So we will work with this problem by just solving 3 equations and 3 unknowns and reverting to matrix operations. So with this one, you can tilt your portfolio towards or away from certain risk factors systematically. For example, we might have these 3 portfolios A, B, and C with the following factor sensitivities that you arrived at using your factor regression. For now, we will ignore A and subsume it into the error term, meaning the constant. It's rather small and we'll just subsume it under the error term. But in finance and investments, A might be the risk-free rate of return. So what you're going to be using in actual finance regressions is the risk-adjusted returns, meaning you're going to have the portfolio returns and then you subtract the risk-free rate. So you're going to have the risk-adjusted returns, which you regress against the portfolio. Okay, so now the question is, what if we want to have a portfolio consisting of A, B, and C such that our final portfolio will have a factor sensitivity of 1 to each factors? For example, if this were a macroeconomic model with factors 1, 2, and 3 being GDP, inflation, and interest rates respectively, we might want to have a portfolio sensitive to each factor by a factor sensitivity of 1. So how much of A, B, and C should we have? This means we need the linear combinations of weights of A, B, and C such that the factor sensitivity will average to 1. For example, you're going to have 1.3 times weight A plus 1 times weight B plus 0.8 of weight C should all average to 1 just for factor 1. So just kindly notice the coefficients and how they're not written in this form versus the way the factor loadings were computed using regression. So finally, this is what we're going to have. We want to have the average sensitivity to be 1 for each factor. Therefore, this translates to just this kind of matrix multiplied by the weight vector is equal to the weight vector of 1s. This is just like 4x equals 1. The solution to that is x equals 4 inverse times 1, or you get simply the multiplicative inverse of 4, just to remind ourselves of what we're actually doing, but this time we're working on matrices. Therefore, we just get the inverse of the matrix and multiply it to 1. And the answer here is this weight matrix of 47, negative 77, and 145%. Now, this means that 47% should be invested in A, 145% invested in C, and we should hold a short position, meaning we're selling a position in B equal to 77% of our portfolio. So also means that 115% of our portfolio is invested and we have borrowings equal to 15% of our portfolio. What if we just wanted to have a factor sensitivity of 1 for factor 1 and 0 for other factors like inflation and interest rates, meaning we don't want to have any sensitivity to interest rate movements or inflation rate. Therefore, we want to create this portfolio using portfolios A, B, and C such that a mix of these 3 portfolios will give us a factor sensitivity of 1 to GDP and 0 to the other 2 factors if we were doing a macroeconomic factor model. So again, the solution is exactly like what we did a while ago. Simply get the inverse of the matrix, and the answer is 132% invested in A and short your positions in B and C by 34% and 47% respectively. So that's how it's done. It's very simple actually to do it. And in summary, you just need to do this, get all your variables and put them in one big soup, extract all your factors with PCA and factor analysis. Then you run your regressions to find your factor loadings. Then if you want to be more sensitive or less sensitive to particular factors, you can optimize, make a portfolio consisting of whatever assets you might be working on and coming up with factor sensitivities using, for example, our matrix operations to compute for the weights. In the future, you can also do this via using optimization methods like what's found in operations research. Hopefully, with these tools and methodologies, you can port the skills that you learn here into your areas of expertise outside of finance. Alright, hopefully that was useful for you. And that's all we have for today. Please like and subscribe to support the channel, and see you in the next video.